Hi, welcome to my channel Cloud with Girish. I am Girish, an AWS community builder and cloud tech enthusiast. In this video, I will share how I used AWS Kiro vibe coding feature to build a customer lookup API powered by API Gateway, Lambda, DynamoDB, and AWS SAM. Unlike traditional IDEs, vibe coding in Kiro lets you code in flow with lightweight prompt. No need to over-specify requirements upfront. It's perfect for experimenting, prototyping, and just vibing with the code. Instead of manually writing services together, I simply gave Kiro a natural language prompt describing what I wanted, and within minutes I had a working, deployable prototype. That's the magic of vibe coding. Let's see what did I build and why. I wanted to create a quick customer lookup API to demonstrate how fast you can go from an idea to a working solution using Kiro vibe coding feature. Instead of manually setting up AWS resources, I described my requirements in plain English and Kiro generated this project for me. Here is what I ended up with. A REST API hosted on API Gateway. This API supports CRUD operations, so it has 5 different functions to get customer by an ID, the post customer, and update the customer and delete the customer. It has a Lambda function for handling requests and a DynamoDB table to store customer data, which include cust ID, name, state, and zip code. It also generated an AWS SAM template for building and deploying the entire stack without ClickOps, so using the infrastructure as code. And then also generated a sample JSON events that can be used to test the API. The goal was not to build a production-ready API right away, but to get a working prototype fast, something I can extend later with authentication, observability, monitoring, and performance tuning. Let's look at architecture. Kiro did not generate it. I created this architecture myself just to show the flow of the event for the code that Kiro had generated. So here a user will request a customer information or will post an information to create a new customer. API Gateway handle that request and it is integrating the API with the Lambda function. Lambda function is processing the request and either storing the data in DynamoDB or getting the data from DynamoDB and returning it back to the user. Prerequisite for this is familiarity with the AWS Management Console, knowledge of Python Boto 3, some basic understanding of AWS SAM, as well as basic understanding of other AWS services used like AWS Lambda, Gateway, DynamoDB, also an event-driven design and architecture. You need to have AWS Kiro installed and ready, and then you also need AWS CLI and AWS CLI in addition to the Python library installed. So here are the steps from prompt to prototype for this customer API. So first we need to start a vibe coding session. So for that, open Kiro, switch to vibe coding mode and simply type a natural prompt. Like in my case, I put the prompt as build a customer lookup API as REST API. API will be hosted using AWS Gateway integrated with a Lambda function. Data will be stored in a DynamoDB table. Create a simple table to store this data with 4 fields: cust ID, name, state, zip code. Do not create test framework as I need to get it quick working prototype first before adding testing and performance framework. I would like to use AWS SAM to build and deploy this solution. So this is my prompt. Let's see what Kiro did. So Kiro responded to me with below answer. He said, I will help you build a customer lookup REST API using AWS SAM with API Gateway, Lambda, and DynamoDB. Let me create a minimal working prototype. And then it created a template.yaml. It created a customer handler Python file. It also created a requirement for dependency and it created a README document. And this is like done really like not even minutes. It was done like in seconds, I would say. And I got this working prototype. So now let's look at the SAM template that Kiro generated. And if you see here in this sample template, it is defining the resources, which is the Lambda function, API, and DynamoDB. And then it's basically integrating it all through the event. So this is my like file that serves as an infrastructure as code. So I can use it to build and deploy the services. It also generated this Lambda function. So in this Lambda handler is basically supporting all different kind of CRUD operation, the get, the post, the put, the delete, and so on. And it's checking for that in the request. And then it has the function defined to get the customer data or post the customer data or delete the customer data, right? So this is the generated Lambda function code here. Let's look at the sample JSON file. So this file also actually created by Kiro only. So Kiro is giving me a sample JSON event that I can use to test this API. So it's saying, hey, get this customer information for this cust ID cust 001. Now that I have all the basic framework in place, the coding has already been done for me. All I need to do is to review it, which I just review the files. And then I just need to build and deploy. So since it already created a SAM template, I'm simply going to use the SAM build command. So if I say SAM build, it's going to build my code. It's actually not my code because Kiro generated it, but it's going to build the code. And then once build is successful, then I can deploy it using the SAM deploy command. So that I'm going to do next here. So I'm saying SAM deploy, and because I'm using the guided options, it's going to ask me the question that, hey, which AWS region I need to deploy. It's going to ask me a few other questions that I can either accept default or I can change the value. And then basically it will deploy the resources. So this concise workflow demonstrates how to create, validate, deploy Lambda function using AWS SAM. By leveraging AWS SAM, you can streamline the development process and ensure that your functions are tested thoroughly before deployment. Now, when it comes to deployment, it's going to ask you that, hey, here is the change set. Should I go ahead and deploy it? So this process is creating a change set that I can review. So in my case, it is building the code, is deploying it, and before deploying is giving me this option that this is the change set. These are the resources that will be created in my AWS cloud account. So once I say yes, then SAM package and deploy the API gateway, Lambda, DynamoDB resources in my AWS account. What that means is that now this service, the DynamoDB and Lambda functions are in my account, and I can validate it by logging into my AWS management console. And then here is what I can check. I can see that, hey, API gateway, my functions are there, my API is there, and all the endpoints are there. I can check for Lambda function. I can check for DynamoDB is there. And of course, it will have a CloudFormation SAM stack. And that's the CloudFormation that it created using the AWS SAM for the deployment. Now that I have the API endpoint, I will use the Postman to invoke the API and will review the response return. However, before I invoke a GET request, I will use the command line to post a record via API that will be stored in the DynamoDB customer table. I need to do that because right now my table has been created, but it has no records. So my command that I'm using is the curl command. So I'm passing a post method with the API endpoint, and I'm passing the data, which is a cust ID of cust 001, name Girish, and so on. And once data is created, I should see a message similar to what's in my screen on the command line. And once data has been created, I'm ready to use the GET API. I will now invoke GET on this API endpoint using Postman. This should return the record that I added to the database. So here is the Postman, and I'm using the GET endpoint, and I'm giving the cust ID, and as you can see that in Postman, I'm getting the response back. Now, this is a CRUD API, so it supports other operation as well. For this demonstration, I just focused on post and get request to create a record and fetch a record using the API endpoint. Now, once I'm done, I typically like to clean up, delete the resources that I'm not using, and that is just to avoid charges in my AWS account. Now, since these resources were built and deployed using AWS SAM, I can very simply delete all the resources using the SAM delete command. It will ask me a few question confirmation, and once I provide that, then SAM will delete all the resources and I should get a confirmation. So in this video, I demonstrated how Kiro made it effortless to create a fully functional current customer lookup REST API integrated with a database using vibe coding to quickly build a working prototype. Not only was the API generated, but an AWS SAM template was also created to support, create, update, destroy, and recreate scenario with infrastructure as code. Generative AI is transforming the way code is built, and tools like Kiro makes the process even easier. While debugging can become more challenging as more code is generated with Gen AI, Kiro's features such as spec-driven development and design documentation generation can help address these challenges. I believe this is just the beginning, and these tools will continue to evolve rapidly. I'm constantly creating new content on various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue producing valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.